Welcome to this explainer. Today, we're going to decode the hidden rules of geometry. By the end of this, you'll see how to turn what looks like a complex puzzle into a series of simple, logical solutions. Okay, let's dive right into this puzzle. Now, this might look super intimidating at first, but it's not about measuring. It's about understanding relationships. And here's the secret. There's a toolkit of 4 simple rules that make solving this surprisingly easy. So, let's build that toolkit. We're going to break down 4 key angle relationships. And once you've got these down, trust me, you'll be able to crack just about any angle problem that gets thrown your way.
First up, we have our corner tool, complementary angles. Just think of them like 2 puzzle pieces that snap together to form a perfect 90-degree right angle. You know, like the corner of a square. So if you've got one, finding the other is a piece of cake.
Next up is the straight line tool, supplementary angles. These guys are partners that always team up to form a perfect 180-degree straight line. Anytime you spot a straight line with another line shooting off it, boom, you're looking at supplementary angles. Okay, so this slide is awesome because it lays our first 2 tools out side by side and really shows you the key difference. Here's a super simple way to remember it. Complementary, C for corner, adds up to 90. Supplementary, S for straight, adds up to 180. Getting that right is honestly half the battle. Our third tool is a massive shortcut when you're dealing with intersecting lines. You know when 2 lines cross and make that classic X shape? Well, the angles directly across from each other, those are called vertical angles. And here's the magic rule, they are always, and I mean always, exactly the same. No exceptions. And our last tool? Well, it's probably the most straightforward of them all. Adjacent angles. Basically, they're just next-door neighbors. They share a wall, which in geometry is just a common ray, and they meet up at the same corner, or vertex. That's all there is to it. They're just next to each other.
Okay, our toolkit is officially assembled, so now let's actually put them to work. We're going to tackle 3 different cases, starting easy and then ramping it up a bit. All right, case number 1. Now the big clue here, the key word is complementary. We're given that one angle is 34 degrees. Our mission is pretty simple. Find its partner, angle B.
And here's how we crack it. First, you just translate that word complementary into a simple math equation. A plus B equals 90. From there, we just pop in the number we know, 34. And a little quick subtraction tells us everything we need to know. Angle B has to be 56 degrees. Done. Okay, let's crank up the difficulty just a notch for case number 2. So this one throws some algebra at us, which I know can look a little scary, but seriously, don't let it fool you. The most important piece of information here is the word vertical, and we know exactly what that means, right? It means they have to be equal. You see? The whole trick is just setting those 2 expressions equal to each other. After that, it's just basic algebra to solve for x, and once we figure out that x is 10, all we have to do is plug that value back into either one of the original expressions to get our final answer. The angle is 35 degrees. All right, for our final and trickiest case, we've got a bit of a word puzzle on our hands. What makes this one tricky is that there are 2 things happening at the same time. We know they're supplementary, and we get this other clue that describes how the big angle relates to the small one. So, to tackle this, we need to set up 2 different equations based on our clues. First, we know they're supplementary, so the small one plus the large one has to equal 180. Second, we turn that word problem into an equation. The large angle is the same as 2 times the small one, minus 30. And now for the magic step. We substitute that second equation into the first one. That lets us solve for both angles, and you find out they're 70 and 110 degrees.
Okay, before we call it a day, we absolutely have to talk about a super common trap. Seriously, this is a mistake that trips up so many people, even when they're really good at this stuff, so you gotta watch out for it.
Yeah, this slide lays it out perfectly. A lot of folks just assume that if 2 angles are next to each other, they must add up to 90 or 180. But that's just not true. They're only supplementary if, and this is the key, their outer edges form a perfectly straight line. Otherwise, adjacent just means they're neighbors, and that's it.
So you might be wondering, why are we spending all this time on a toolkit for angles? Like, does this actually matter out there in the real world? And the answer is a big yes. Let's zoom out and see the bigger picture.
You know, these simple rules are actually the bedrock of things like structural engineering. Think about it. When you see those giant X-shaped steel beams on a bridge or a skyscraper, you're literally looking at vertical angles at work. Engineers count on the fact that those opposite angles are perfectly equal to make sure all the forces are balanced out and the whole thing doesn't, fall down. And looking down the road, This isn't just some random geometry topic you're going to learn and then forget. This quote from Baker's math class really nails it. All this logic with complementary and supplementary angles, it's the foundation, the essential first step into the way bigger and honestly way more powerful world of trigonometry.
So, as we wrap things up here, I want to leave you with this one thought. What you've done today is you've unlocked the basic code for how angles relate to each other. And these aren't just some abstract rules for a test. They're the literal building blocks you'll need to understand everything from massive bridges to the kinds of waves and circles that are all over trigonometry. So yeah, you're ready for what's next.